In this video, we're going to explore the graphical relationship between a function, its derivative, and the second derivative. And just like its name sounds, the second derivative is simply the derivative of the first derivative. Let's look at example 1. We have a function here, f of x equals 1/2 x cubed plus x squared. And the first thing I want to look at is where is f of x increasing and decreasing. So the word increasing means going up, and I'm going to use a lot of colors on this video, so you may want to pause and grab some colored pencils or some highlighters or something to follow along with in your notes. So increasing means the graph is going up. So you can see clearly that f of x starts out increasing, if you just want to call that negative infinity, until it hits this point right here, maybe negative 1.3. And then it starts to decrease from that point until it hits 0, 0. You can see that it's going down. Decrease just means the graph is going down. And then it turns again and begins to increase from 0 on to infinity. So this graph goes increasing, decreasing, increasing. So I'm going to look at this same interval. I'm just going to extend these dotted lines down on the first derivative graph. And I want to see if I can figure out a relationship between the first derivative and the function. So if you notice, at these interval points, at negative 1.3 and at 0, 0, the derivative equals 0 here. And if you look at the tangent lines on the function graph, remember derivative is slope of a tangent line, at both of those places the tangent line is horizontal, which means the slope is 0. And so you can clearly see from both the function graph and the derivative graph that the slope is 0 at negative 1.3 and at 0, 0. So then the question is, what is the derivative graph doing when the function is increasing? So if you look at both increasing intervals, there isn't really a relationship between increasing and decreasing. In the first interval, the derivative graph is decreasing, but in the second interval, the derivative graph is increasing. But what they both have in common is that they're above the y-axis. They're positive. So the derivative graph is positive, where the function graph is increasing. And so then the question is the derivative graph negative where the function is decreasing? And you can see that where the function is decreasing, the derivative graph is underneath the y-axis, so it is negative. So on my chart here, I'm going to list this relationship. So when the function is increasing, the first derivative is positive. And when the function is decreasing, the first derivative is negative. And in my second column of graphs here, we're going to look at the relationship between all three, the function, the first derivative, and the second derivative. So I'm going to actually start with the first derivative. If you notice, because the second derivative is the derivative of the first derivative, they're going to have the same increasing, positive, decreasing, negative relationship. So let's look where f prime is increasing. F prime is going to increase from this point on to infinity. So it's changing right here. And that's maybe, I don't know, negative 0.8, something like that. What's happening at negative 0.8 on the second derivative graph? Well, it's equal to 0, because again, that's where the tangent line has a slope of 0. So if we extend this down, you can clearly see that the second derivative is positive, where the first derivative is increasing. And then the first derivative is decreasing, and the second derivative is negative. And so this first derivative is decreasing, and the second derivative is negative. Okay, so let's extend that back up to the function graph. Let's take the same line up, right about here. What's happening at the function graph at negative 0.8? And this one might not be quite as obvious to you, but if you look where, in this interval, we're going to look at the shape of the graph. And this shape is what we call concave up. That just means it's a nice U shape. It's facing up. And so the function is going to be concave up when the first derivative is increasing and the second derivative is positive. So let's fill that into our chart. Concave up function means increasing first derivative, which means positive second derivative. And similarly, if you look where the derivative is decreasing or the second derivative is negative, you see that the function graph is what we call concave down. It's an upside down U shape. It opens down. And so the same relationship, the function will be concave down, where the derivative is decreasing, and where the second derivative is negative. This chart is going to be very important to things that we do in class. You are going to want to memorize this chart. We're actually going to quiz you on this chart. You will need to know this chart for the rest of the year, so please make sure that you have this chart down in your notes and that you memorize it. So let's look at the concavity shapes a little bit more. There's basically 4 shapes to the graph. They're the 4 pieces of U's, whether they're concave up, like the top row, which just means they're the part of the U that opens up, or concave down, like the bottom 2. And again, they're just pieces of U's. These are the basic shapes that you see in graphs, and they may extend on to infinity, but these are the basic curves that will make up any polynomial function. Or we can also look at increasing and decreasing. These 2 right here are increasing. They're going up. And these 2 right here are decreasing. They're going down. So let's try to think about what's happening to the first and second derivatives when we have these shapes of the graph. And we're going to do that by looking at the tangent lines. So I'm going to draw a tangent line somewhere on the curve. And you can clearly see that the slope of that tangent line is positive. So we know that the first derivative has to be positive. The other thing we want to look at is what's happening to the tangent lines as you go across the curve. So let's draw in more tangent lines. You can see that the tangent lines are getting steeper, which means that they're getting bigger, which means that their slopes are increasing. And then the second derivative, if the slopes are increasing, the second derivative also has to be positive, which we also knew because the function's concave up, which means the second derivative has to be positive. So let's look at the concave up decreasing. You can clearly see that the tangent line slope is negative, sloping down. And if we draw in more tangent lines, these tangent lines are getting less steep, but we're starting with a very large negative slope, and that slope is getting less steep, so it's approaching 0. So if you start with a large number and you approach 0, your values are actually increasing. So the first derivative is increasing here. And because it's concave up, and because the first derivative is increasing, the second derivative has to be positive. Okay, so let's look at concave down. We're going to do the same idea. Let's draw in a tangent line. It has a positive slope, so we know the first derivative is positive. Okay, so are the slopes increasing or decreasing? So in this case, we start out with a very steep positive slope, and the slopes get less steep as you go up the curve, which means they're getting closer to 0, which means they're getting smaller. So in this case, the derivative is decreasing. And the second derivative, because the first derivative is decreasing and because the shape is concave down, has to be negative. And the last shape here, again, let's draw in a tangent line. The slope is clearly negative. Is it increasing? Is it decreasing, the slope? Let's see. So if we draw in the tangent lines, it starts out with a pretty flat tangent line, which is close to 0, and then it gets more steep. But it gets more steep in the negative direction. So it's getting more negative, which means the numbers are actually getting smaller. If we're going from 0 to -1 to -3 to -5, those values are decreasing. So our slope is decreasing here, which means our second derivative is negative. So these shapes are going to be very important. You want to be able to recognize these concavity shapes, and you want to be able to think about what that means about the first and the second derivative. Okay, so we're going to do an example. of how this may show up in class or on the exam. We're going to refer back to our table, so I've put it up here again, but you can refer back to it in your notes. Okay, so let's look at this first graph. Using the graph in the derivative of f, using the graph of the derivative of f of x, answer the following questions. So it's very important to pay attention to what kind of graph you have. You may have a function, you may have a first derivative, you may have a second derivative. So in this case, we have a first derivative graph. So the first question says, where is the first derivative positive? So what we're looking for is, where is the first derivative above the x-axis? And so you can clearly see that it's here, here, and here. And so we're going to write this in interval notation. So I'm going to do parentheses. Because there's an arrow here, this starts out at negative infinity, and then it's positive until you hit -3. And because there's more than one interval, I'm going to use a union symbol, which is just a U, and it just means and. And then I'm going to go, my next interval goes from -1 to +2. And then there's one more interval, so I put another U. And that interval is slightly past 5, I don't know, maybe 5.2. You can just approximate. And because there's another arrow on the end, we're going to put an infinity symbol here on the end. And honestly, infinities should always be open parentheses. But for the other points, we're not too picky if you use a bracket or a parentheses. I mean, technically, you can't be positive at the zeros, so you should use a parentheses. But if you use a bracket, we won't hold it against you. And so then the other side of that is, where is the function negative? Where is the derivative negative? And so you can see that where it's below the x-axis. And so again, we're going to write that in interval notation from -3 to -1. And because there's another one, use your U. And then it's from +2 to 5.2. Okay, where is f prime of x increasing? So that is, where is this graph going up? All right, so this graph is going to go up from, let's see, this point here, which is slightly past -2, all the way to this point right before 1. And then again, looks like right about 4, all the way to infinity because there's an arrow. So you can just approximate when it's not exactly, I don't know, this might be -2.2 to positive 0.7 maybe, union, and then from 4 to infinity. So we're going to do the same thing with decreasing. That would be starting up here at the top, and then the graph goes down, 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 down until we hit -2.2 again. So we have negative infinity to -2.2. And then it also decreases from this 0.7 to 4. So where does f of x equal 0? So that is simply, where does it cross the x-axis? So that's 1, 2, 3, 4 points. So we have x equals -3, -1, 2, and 5.2. Okay, when is f of x increasing? Okay, so now this is different. Notice they're now asking us about f of x, not f prime of x. So we cannot just read off the graph the interval of increasing. This is not the same as part C, where it says, where is f prime of x increasing? So please make sure you pay attention to the difference. So if you come back to your chart here, we want to know where f is increasing. So on the derivative graph, we have to look at, where is f of x, f prime of x positive? So if we go back up top to part A, where is f prime of x positive? That's going to be the same as where is f of x increasing. So be very careful that you read the differences. It makes a big difference if they're asking for f or f prime. Okay, so same thing for where is f of x decreasing. You want to know where is f decreasing, but you have to look at the f prime graph. So you have to look at where is f prime negative, and that was part B. So we're going to use -3 to -1, 2.5 to 2. Okay, part H says, when is the function concave up? And so if you look at concave up, we are looking at where is the first derivative increasing. So that would actually take us back. So we want to know where's the first derivative increasing. So we look up, we answered that in part C. So that was negative 2.2 to 0.7 and 4 to infinity. Where is the function concave down? So again, concave down relates to where the derivative is decreasing. So we're going to look on the where did it ask us about the derivative decreasing? That was part D. So that is negative infinity to negative 2.2 and from negative 0.7 or from 0.7 to 4. Okay, part J says, where is the second derivative positive? So if I want the second derivative to be positive, again, I'm looking back at the first derivative. Where was it increasing? So again, we answered that. F prime increasing, we answered that way back up. Let's scroll back up a little bit in answer C. So we are looking for negative 2.2 to 0.7 and then 4 to infinity. Okay, where is the second derivative negative? So second derivative negative, we have to look at the first derivative graph. So we're looking where was the first derivative decreasing. And we answered that in part D. That was negative infinity to negative 2.2 and 0.7 to 4. And for the final question, it wants to know where does the second derivative equal 0? So we want to go back to the graph for that. The second derivative equals 0. It's the slope of the first derivative. So we want to know where would our tangent lines be horizontal. And so that's going to happen at what we call the mins and maxes of the graph, or the extrema of the graph. So the tangent line is 0 right there at negative 2.2, at the 0.7, and at 4. Okay, we're going to have you try one now. Take a minute, try to answer these, refer back to your chart, pause the video, and when you're finished, unpause the video and the answers will appear. Okay, here are the answers. Check your answers, bring your questions to class.